次は招待講演セッションです。私は1件目のセッションの司会を務めます30周年記念事業実行委員の井上です。よろしくお願いいたします。まず最初に連絡事項です。質疑応答は、会場の方はこちらにスタンドマイクありますので、こちらをお使いください。でオンラインの方は、Zoom の QA 機能を使って質問をご入力ください。ティム先生のご講演、日本語、英語で両方されるということですけれども、質問も日本語、英語どちらでもかということですので、どちらの言語でも、ご入力ください。では早速講演に移っていきたいと思います。本講演の、招待講演者、ティム・ボールドウィン先生です。ティム先生は東京工業大学、現在の東京科学大学で博士号を取得された後、スタンフォード大学、メルボルン大学でリサーチャー、プロフェッサーをされ、2022年からはムハンマド・ビン・ザイード人工知能大学に拠点を移され、現在はプロボースト、プロフェッサーとしても大活躍されています。ご研究は感情分析、QA、公平性といった非常に幅広い分野についてされていて、目覚ましい研究成果を上げておられます。今回は The Long and Winding Road of NLP Reflections on the Last 30 Years というタイトルでご講演をいただきます。それではティム先生、よろしくお願いいたします。
ありがとうございます。ただいま紹介に預かりましたティム・ボールドウィンと申します。今回は言語処理学会30周年記念にあたっておめでとうございます。招待講演をさせていただきます。で、冒頭は日本語で、自分なりの紹介、題しまして、言語処理学会と私っていう題で少し簡単に説明をしまして、後半は英語に身勝手ながら切り替えて、もうちょっと30年間の自然言語処理の流れ、経緯、を、自分なりの感想を交えて振り返りたいと思います。よろしくお願いします。はい、ご存知のことの方もいるかと思うんですが、言語処理学会とのつながりっていうのが、95年東工大に最初に研究生として来た時から始まって、当時の、田中徳永研究室の、研究生で、そこからマスタードクターを経て、それからスタンフォード大学の方に行きましたが、田中先生が初代副会長、長尾先生に次いで、2人目の会長になられた方で、その当時の研究室の、映像がちょっとだけ残ってたので、懐かしい思いをしながら皆さんにお見せしたくて、今日は田中先生の研究の知を受け継ぎながら代表して、発表したいと思います。で、95年から、日本来日して研究生としてNLP の旅を始めたわけですが、ちょうどその翌96年に、東工大で第、2回の年次大会っていうのが開かれまして、そこが、自分の NLP の本当に最初の、会議となりました。で、過去データを振り返ると驚くことに2回目でありながらも、その論文数が、108件もあって、これは自分の記憶の定かではない数字ですが、参加人の、人数が、約150人。当時としてはもうなかなかの大きいその国際的な会議から言っても、もうかなり活発な人口の多い学会だったっていう記憶があります。で、パラレルセッションは当時 としてはもうすでに3つもあって、その年の自分の初めてのそういう会議の基調講演をされたのが、韓国の知恵先生、今カイストの先生をやられてます。で、田中先生の写真を出してしまったので自分の恥ずかしながら、これドクターの時の自分の写真なんですが、ピッチピチの自分です。で、翌97年、第3回年次大会で、もうその NLP のその第一歩目の本当に一歩目の論文を、発表しまして、ちょうど昨日来る途中の飛行機でその当時の OHP を探し出して、コンパイルできるのかをやってみたら、もうラテックと Linux の素晴らしさでもう一発でコンパイルができて、もうこの通りその本当の当時の OHP の様子です。もちろん印刷して透かしの状態で発表したわけですが、もう本当の OHP で。で、その3回目にしてちょっと論文数がまた増えて144本。これももう自分の記憶からするものでここまで多かったのかどうかはわからないんですが、大体200人ぐらいの方が集まってパラレルセッションがもうすでに4つにまで増えてました。でそこから97年98年99年2001年2年と4年大体8年間ぐらいを経て、9本の、論文を言語処理学会年次会で論文を、発表しまして、1回だけ優秀論文をいただきまして。で、この話は、多分ご存知の方は少ないかと思うんですが、CSLI に行ってから言語処理学会と日本語自然言語処理に特化した、本のシリーズを作りましょうっていう、当時の中川先生、石崎先生、島津先生にも大変迷惑をかけながら、少し自然言語処理学会から支援をいただいて、で、その学会誌から論文を集めて英語に英語になっていなかったものを翻訳していろいろと編集してやっとこの一冊目ができたわけですが、もう一冊だけでそのシリーズが途絶えてしまってもうかなり珍しいものになってます。で以上自分とその言語処理学会とのつながりでした。ということでここからは申し訳ないんですが英語に切り替えます。So, I now switch over to English because my Japanese is not up to research presentations. I'm a bit rusty, I have to confess, as you will have seen. So I wanted to spend a bit of time just reflecting on where we've come as a field. It's been a long and winding, perhaps not quite as old as the Beatles, but time over those 30 years. And I spent quite a bit of time looking back over old proceedings of both the Natural Language Processing Association annual meetings as well as ACL, and reflecting on, where have we come? How have things improved? What's the good news in terms of what we've done over the last 30 years? What has stayed the same? So actually reflected a lot on issues which may feel new to the younger generation, but actually they've been recurring themes over those last 30 years. And I think there are some learnings from where we've come along that road to reflect on in terms of making sense of where we are. A little bit of what lessons have we forgotten? What were we better at in the past, I would argue, so being a little bit controversial. And then signs of the times, a little bit of analysis that I did at the end before I finish up. So I'll start out with what was improved. And there's lots of areas in which we've improved, a lot less of where we've stayed the same and where things have regressed. So in no particular order, one of the things which has changed a lot in the last 30 years is evaluation. So in 1995, automatic evaluation was a very, very primitive area. A lot of the evaluation that we did was manual. The automatic evaluation that we did was for sort of fairly simple, discrete tasks like part-of-speech tagging. They didn't feel simple at the time, but in terms of evaluation, they were simple because there's a discrete representation to do evaluation over in terms of accuracy or labeled accuracy or labeled precision or things like this. So it was always relative to some discrete representation, whether that's a nested representation in the context of constituency parsing or templates, so sometimes nested themselves for information extraction, template filling, MUX style. But outside those areas, so particularly in areas like machine translation, which is where I did a lot of my earlier work, evaluation was manual, it was small scale, and it was largely over in-house data sets. It was before the days of WMT, where we had shared data sets that everyone was using. So different teams had their different in-house data sets. Some of them released them, but a lot of them didn't. And they would publish over those data sets, which is a funny thing to say now, something that the reviewers would not let you get away with. So the good there, so for each of these, I have a reflection in terms of how this is a good thing and perhaps where it's a little bit of a double-edged sword, areas where we have to be a little bit careful, or we have to be mindful of where this has brought us. So the good here is obvious. So in being able to automate the evaluation of different methods, and I'll come to this in the next bullet, but with then the availability at large scale nowadays, something we absolutely take for granted, of standardized evaluation data sets and automatic training methods, recipes for doing evaluation and scripts for doing evaluation and leaderboards and things like that. It's absolutely revolutionized areas like machine translation and summarization, where level playing field evaluation was a very, very difficult thing. It really wasn't possible at the time, and it's driven massive, massive progress in those fields. I would argue that we wouldn't be where we are in neural machine translation if it weren't for automatic evaluation metrics and large-scale evaluation data sets to train our systems on and measure progress. But it's not all rosy, so I think it is worth reflecting on some of the issues that have come along with automatic evaluation. Some of them are perhaps surprising. They're niggles, but niggles where if I'm comparing my numbers against your numbers, they're important niggles. The first one of these is notorious. So even for things like blue, say for a MT evaluation, what was sort of found and fixed then if you used Sacra Blur, the map post implementation of Blur, but how you tokenize what you considered to be a word had quite a big impact on the numbers that you got in terms of your blue scores. So people had their own ways of calculating blue, meaning the numbers weren't actually comparable. And there have been similar findings elsewhere for rouge, for example. So standard implementations of these, of course, are very important. Perhaps more worrying has been an over-reliance on these metrics, particularly given that they're always going to be imperfect. We will never have perfect evaluation, but an over-reliance, over-interpretation perhaps of small differences in some of these scores. And there've been various papers, including some of our own, to expose this effect, that you really need to have a fairly large difference in blue scores and really don't use blue as much as possible. There are much better evaluation metrics, which you don't have overconfidence in small differences is something that we've kind of learnt the hard way. And it's maybe a cultural thing, but hill climbing behaviours, again, it's a corollary of over-interpreting small changes and being too fixated on numeric differences without actually looking at the outputs of the system and reflecting on, is that a meaningful difference you're observing there with some of these small numeric differences? So another area which is completely different, it's so much easier nowadays than what it was certainly 30 years ago, is natural language generation. So back in 1995, and yes, it makes me feel old talking about 1995, generation was a fairly primitive field. It was hard. It was almost the hardest area in NLP. And what people did in generation tend to be based on symbolic methods, rule-based methods, templatic methods of different types for text-to-text generation tasks, at least, like summarization or machine translation. Or if it were more dialogue system style, more open-ended text generation tasks, it tended to involve planning, so symbolic representations, then generation from those. And it was right around the time that the IBM models had been proposed. The jury was still out as to where they were going to take us. And then soon after that, we had some of the groundbreaking work of people like Kevin Knight in terms of nitrogen, but it was still all N-gram-based, N-gram language model-based. And it just didn't scale to larger text. So sort of short sentences, fine. Longer sentences, you get local fluencies, but even within a longer sentence, you get longer distance disfluencies. And certainly longer passages they did not scale to. And then there was a very large cottage industry in NLP in terms of coming up with better and better or different smoothing approaches for N-gram, what we would now call count-based language models. And yeah, that was very much where the focus was for 15 years or so ago, or 15 years or so, until work came out, not really from NLP, honestly, from more speech and machine learning in terms of neural language models. So despite the fact that we were using them heavily in tasks like machine translation, the real innovations actually came from elsewhere. We were somewhat caught with our pants down, honestly, as a field. So in terms of what we can do now with natural language generation, there are lots of goods here. So in having neural language generators, they're much more data and parameter efficient than what we used to have with the N-gram models. They're fluent. We can do much longer context generation much more successfully than what we used to be able to. They generalize better over unseen data without having to do lots of low-level smoothing tricks. They're much more flexible in terms of what we can do now with instruction tuning. And the bads here may be less bad than in some of the other contexts. So controllability, you could argue, if it's a text-to-text problem like machine translation, I don't think this is a major issue. If it is more of an open-ended generation task, controlling the models does become harder in terms of what they're attending to and generating from. And fine-grained control is definitely missing in our current methods. Interpretability is something that we talk about a lot and lament, although if it is text-to-text problems, maybe it's less of an issue. And it's less clear how to incorporate, if we are doing longer distance, document length, book length, generation, which is something which is feasible nowadays, given the very large context sizes that modern models are supporting. So the ideas from planning, some of these old ideas from 30 years ago are very much coming back in, but exactly how to incorporate them is an open problem. I don't think anyone's really resolved that, although there's some very interesting work coming out in terms of using LLMs themselves to do the planning. So then multilinguality. We just couldn't conceive 30 years ago of multilingual models in the way that we talk about them today. So multilingual systems were very much built pairwise, and even worse, pairwise and direction-wise. So while I was a student, I was fortunate enough to be able to work with the NTT. We have some people here from NTT, it's wonderful to see. The OutJE system, which was Japanese-English, and it only did Japanese-English, it did not do English-Japanese, the other direction. It was very heavily built around processing Japanese and generating English. And the only way that we really had at the time, other than doing pairwise data-driven methods like EBMT to do what we would now call multilingual, as in end-to-end over different combinations of languages, machine translation, was via interlingua. And interlingua are hard. Interlingua over large numbers of languages where we have typological differences between them, getting some intermediate representation which captures all of those differences. We had a wonderful presentation about UD before. UD is simple compared to interlingua, and UD is very hard. So there was a lot of work that went into it which didn't get very far in terms of really compelling results. And in NLP, the assumption was if we were doing anything multilingual, then we needed to have a staged processing pipeline. We needed to do language identification first, identify what the languages were, and then we'd switch over to our monolingual models appropriate to whatever spans we had for the different independent languages. And it was really only it was the speech people who were ahead of us. So there was earlier work talking about multilingual language models, which makes more sense in a speech context, or where it would be coming from in a speech context is perhaps more obvious, at least. If you are doing multilingual speech recognition, or at least you don't have any guarantee that it's in one particular language, the idea of having a multilingual language model makes more sense. So again, the speech people were very much ahead of us here. Okay, and there was some work in terms of doing bilingual transfer, particularly from a high resource language to a low resource language, again, largely for tasks like part of speech tagging and parsing, for example, but it was always pairwise, and it was always higher to low resource languages. So in terms of what we can do now with multilinguality, the cross-lingual transferability, the fact that even small amounts of language where combined with large amounts of data for other languages, we're finding a lot of cross-lingual transfer, so a lot of complementation from larger languages, even for languages which are quite distinct. We saw examples with this with some of the work we've been doing with English Arabic models at MBZUAI, where they're surprisingly good machine translation engines for languages like Malay, which, yes, it's hidden away there in our training data somewhere in some small amount, but the fact that the model can generalize to do machine translation of a language pair which has never been instruction tuned and is only sort of there in trace amounts in the pre-training data is absolutely mind-boggling. Data and parameter efficiency as well. So again, getting generalization or parameter sharing between languages and flexibility to use these monolithic models to do all sorts of tasks where we perhaps only have supervision within one language or one language pair, and we can do it relatively well for language pairs where we don't have direct supervision. Of course, it's not all rosy, so we do have issues in terms of models, finding it hard, particularly for very closely related languages or dialects, getting confused. It's hard to get pure output in one dialect without large amounts of training data for that dialect and fairly clean tagging of the data, which when it comes to dialectal data is very hard. Language switching, I'm sure we've all observed for some of the multilingual models, they'll suddenly switch over to Korean for no apparent reason and then perhaps come back to English. So you do occasionally get these, not hallucination effects, just almost show-off effects that for some reason, for this particular context, I find it easier to speak in Korean, so off I go. And of course, something that I'll come back to at the end, cultural biases. Linguistically, these are a great idea, but if you're interested in cultural norms and sensitivities for smaller languages, you tend to have very strong biases coming from the larger languages, particularly from languages like English. So this is more of a cultural one maybe, and it's something that we very much take for granted today. But again, 30 years ago, it was in a very limited form still. Open source, the idea that people release their data, release code, release trained models even, that I can use, you didn't have a lot of it. 30 years ago, meaning you had to build a lot of things from scratch, which was great training, but was very limiting if you were trying to do anything at scale. And Japan, I would argue, is actually a pioneer in this space, sort of through the late 90s into the early noughties, with things like Jiman and Chasen, and machine learning toolkits that came out of NLP, like TinySVM. Then for English, of course, you had things like the Brill tagger and Ratnapaki tagger, so English part-of-speech taggers. The Charniak parser came a little bit later, followed by the Stanford parser. And I think that really sort of started the landslide of people realizing that the importance and value of open source. So there are lots of goods here. I don't know if there are any real downsides to open source. So reproducibility, of course, if I can use the same reference implementation of a particular learner or a particular tag or whatever it is. Modularity, because I can build off the components of other people. Tractability, in terms of I can relatively easily combine together different components to make something more substantial. With the only possible bad maybe being black box usage. And I guess there are subtle examples of this with perhaps reference implementations of transformers from Hugging Face, and people sort of find that actually it's doing gradient clipping before it's doing gradient normalization, saying, and everyone's been using this without really thinking about it, because, well, it's the Hugging Face implementation, so it must be right. And okay, at least we're all doing the same, subtly not quite right thing. So it's not a major thing, but it does mean that you perhaps learn to over-rely on these open source resources without actually looking at the code yourself. Related to this very closely is the idea of dataset development and sharing. And it's partly the sharing of the datasets themselves, and it's partly sharing the recipes, the annotation guidelines, the learnings from building all of these resources. And we saw some fantastic examples of that in our 2 paper awards earlier. So back in 95, if there was data sharing, it tended to be very small scale data sets, making it very hard to do standardized evaluation, of course. And there were early signs of where we've now ended up within NLP. So the Penn Tree Bank, for example, it existed prior to 93, but the paper, the eponymous paper associated with was published in 93. Of course, you had the Muck data sets, which from the early 90s, although I guess that was coming out of DARPA efforts, so it tended to be people involved in DARPA projects who were involved with it, but the data was available. And these were major catalysts, not just for parsing and IE, but for a lot of the component tasks associated with them, things like part-of-speech tagging, named entity recognition. One of the things that this, I think, has led to, as well as being able to follow recipes and getting access to these data sets, is also critical evaluation of the composition or validity of some of these data sets. So an example of that would be some of the work that was done at AI2 and other institutions in terms of data set artifacts. The fact that for paired data, I can ablate one half of the pair and still get higher than random results, suggesting that there are artifacts hidden away in the data. And if we got access to the data, of course, we can perform these sorts of analyses and learn more about perhaps unintended consequences of how the data set was constructed and improve it variously. So again, lots of goods here. More training resources for our models, more task variety. Just the range of different data sets that we have is truly unimaginable from where we were 30 years ago. We can do more comprehensive and varied evaluation. So even if it's the same task, we have many different data sets or the same representation, like universal dependencies. We have tree banks over all of these different typologically diverse languages. It's a fantastic resource. Of course, but greater reproducibility. And what I mentioned at the end, this ability to critically evaluate how we're doing evaluation and build on that. And the bads here are perhaps more cultural in terms of what people do with them, or how people get used to just downloading a data set and off they go. The unintended consequence of the convenience of things like Hugging Face. So part of it is perhaps having what are not necessarily particularly good data sets, or not the best version of a particular task, becoming popularized and people sort of using that beyond perhaps the true value of that data set. And I would argue there are some English summarization data sets like XSUM and CNN Daily Mail, which would fall into that category, that they've vastly outlived their usefulness as data sets. There are flaws that we should be moving beyond. A little bit of complacency, I'll come back to this at the end, in terms of people just assume that data sets are there, ready to download and off you go, without really thinking about the true cost and effort that goes into to building these things. So, kind of a complacency or an assumption that, yes, these things just fell from the sky somehow without really realizing all of the blood, sweat and tears that goes into them. And yes, a very modern one, this risk of data contamination, which is, again, not a criticism of data sets. It's whether it's deliberate or not, a hazard if we're training large-scale models on every possible data point that we can find, that using these to then do evaluation, they're contaminated, so we can't meaningfully do held-out evaluation over them because the test data set is potentially actually in the pre-training data. So then end-to-end models, general purpose models, whatever we want to call them, Swiss Army knife models in terms of what we have now with LLMs of different varieties, or foundation models of different varieties. So 30 years ago, everything was very much siloed, very specific tasks that we broke things down into. You had your sentence tokenizer and your word tokenizer and your part-of-speech tagger and your segmenter if we're doing Japanese, and then possibly a separate, hopefully not, part-of-speech tagger and chunker and parser, and so you go on. And pipelining these together, of course, was a recipe for disaster because you would propagate the errors. It was a bit of an engineering nightmare in bringing all of these together until some of the major libraries like Core NLP and NLTK started coming out. And some of these tasks were quite divorced from downstream use cases for them. Not that we were too fixated on use cases, perhaps 30 years ago, but what we have sort of found since is perhaps what we had assumed in terms of constituent parsing, for example, being a critical element of natural language understanding, or the ability to perform true NLP, finding that, no, you don't necessarily need to have a discrete parser in order to do things. Of course, now with LLMs and prompting and related interface methods, we suddenly find ourselves with the ability of using these very powerful monolithic models to do all sorts of things, tasks beyond what they were actually trained to do within one single model. And there was a wonderful blog post from the Sanford HAI group in the last week or so about some of the possible use cases for LLMs, way beyond anything that they were actually intended for. So this particular case was processing, I think it was 5 million records in terms of land records in California to identify and redact, as well as map racial covenants. So these are sort of horrible things related to exclusionary clauses based on race that are sort of still there from olden days, and legislation now is requiring are removed, but it's a very, very large-scale task. I mean, it's over 5 million records, and they found that using LLMs over some noisy OCR data, you can do this very successfully. Just one small example of the power of LLMs. So the good here, they're flexible, they're generalizable, they're robust, somewhat. You can do a lot of things with them. How well they perform over different tasks can vary, of course. They sort of scale in surprising ways. but they can be overconfident. Models tend not to refuse to give you an output because they don't have the answer, or they're not confident in their answer. You may sometimes have the model refusing to give you an answer for other reasons. Of course, we know about hallucinations. So model refusal, so this idea that, okay, I'm trying to inference over some test data, and for this instance, it just won't give me an output. Just what do I do with that? It's a very, it's a bit like having a dog which refuses to walk one day. That, well, that's not a very useful dog that I'm supposed to be taking it out for a walk. So they're finicky things to play around with at times, and lack of consistency. The idea that I need to inference multiple times and do some averaging over the outputs to really understand how well they perform. So then is the culture of shared tasks, and again, it relates to data sets, but I think it's bigger than that. This came, I think, very much out of the successes we were observing in information retrieval with TREC from the early 90s. And I guess the earlier instantiations of this in NLP were things like MUC that I mentioned before for information retrieval, template filling style. Connell started its series of shared tasks with noun phrase chunking back in 2000. SensorVal, what became SemaVal, started up in 2000. So sort of late 90s, early noughties, there was suddenly a proliferation of shared tasks, and the word entered the NLP lexicon in a very big way. This, I think, has had a defining influence on NLP in terms of helping establish new tasks, in sort of particular paradigms with respect to how some of these data sets and evaluation methodologies have been set up. It's had huge impact. So catalyzing research is a great thing to come out of them, standardizing evaluation benchmarks, lowering the bar to playing around with some of these tasks because the data is there, the evaluation scripts are there. You've got a lot of literature in most cases in terms of what people have done with that data. The bad is there are certainly some cases where perhaps what has been the defining, the canonical data set associated with a particular task, there's been work that's been done since then, which is arguably better in quality, larger in size. Things like the old Connell named entity recognition data set should be retired at this point, but it still, of course, creeps into research because there's been so much work done over it. There are instances where the task organizers themselves sometimes have, in earlier iterations of the shared task, come up with a particular formulation and struggled to change that. They've sort of been stuck in this local minimum as a victim of their own success because it's been a very popular task. They want to change it radically, and there's actually a lot of resistance from the community in terms of people being used to doing it in a particular way. So then one very big area now, AI safety or responsible AI, which is a very recent invention. Now, it's not something we ever talked about 30 years ago, is, I think, a very good sign in terms of our maturation and realization as a field that we are building tools that people are using which are making a difference on their lives, and we have a social responsibility in terms of what we're putting out there. So this is the idea of aligning our models with whether it's cultural or content-based or value-based norms to safeguard users in different ways. Okay, and you could argue somewhat cynically perhaps that, well, there are any recent concerns because, and I heard this a lot from my information retrieval colleagues when I first moved to Melbourne, NLP wasn't relevant until fairly recently, so no one was ever going to use it. You didn't need to worry about AI safety. I don't fully believe that. It's only with LLMs, with their hyperparameterized, unpredictable nature, lack of controllability, that it's become an issue precisely because of that lack of controllability. And I think there's some truth to that, but I would equally suggest that some of the rule-based systems 30 years ago, you would occasionally get collocations which are certainly not intended and had meanings beyond what the developers ever would have hoped in terms of the output. So you definitely did get embarrassments in the output. But I guess as part of the flexibility and the generalizability, it was always within bounds, I guess, that you were going to get those embarrassing outputs. Okay, and I mean, for me personally, and some of you have heard me talk about this in talks I've given elsewhere, my personal awakening moment, if you like, came in the context of earlier work we'd done with language identification, a tool called langid.py, back in sort of 2010 to 2012, and the finding from a group at Stanford, David Jurgens and co, that there was a very strong bias, which correlated very worryingly with human development indices. So basically, for richer countries and the varieties of English spoken in richer countries, it had much higher recall if we were using it to filter English from non-English tweets, for example, than for varieties of English spoken in lesser developed countries. So basically creating a dynamic of rich getting richer. It works well for the rich, it doesn't work well for the poor. And this is what you would have thought is a fairly benign task like language identification, not something where, certainly when we were developing the model, we would have expected. So this was my moment of, wow, this is my model. Lots of people are using this model as part of my social accord with the community and all sorts of weird and wonderful use cases that people are coming up with for it. I need to be sure that I'm not getting some of these biases in terms of the output or instances of unfairness. Okay, and as LLMs are being used more and more, obviously the potential for good and bad use cases increases, as does the complexity as these models grow and grow in size of even evaluating, but certainly imposing meaningful safeguards on them, having some confidence that we're not going to get horrible outputs from them or hurtful outputs of different types. I need to speed up. So the onus is on us to really make this right, and there's a lot of work to be done here. So the good is, I think, this coming of age moment for us as a field, and there are then three things which are both goods and bad. So it's good in the sense that it leads to detailed understanding of the models if we're doing this right, but we don't really have that. There's a chicken and egg problem there. It's good in the sense that there are very hard research problems to be tackled, but that also means there's a lot of work to be done to really achieve demonstrable AI safety. And to do this properly, we have to work very closely with people in psychology and law and sociology. And it's hard to build those relationships and do meaningful work which is truly deeply engaged with these people. So lots of very important work to be done, but it's not going to be easy. Cultural NLP is another one. I might skip over this in the interest of time. And also branching out beyond just language into other fields, whether that's biological or clinical or legal, or so there's a lot more work that's interdisciplinary, and not just language interdisciplinary, different data modalities interdisciplinary, which again wasn't believable 30 years ago. So what has stayed the same and where have we regressed? So there's a lot of talk about data scalability and compute scalability of current generation LLMs and data scaling crises. And I think it's important to realize that this isn't actually a new concern. This is something which came up in a very big way in the mid-noughties, so almost 20 years ago, partly in the context of what was called Googleology at the time. So this was using commercial web search engines because of the scale of data that they'd indexed to derive page counts for what I'm calling here lexical fingerprints. So I can compare the counts associated with a lexical fingerprint that would be associated with one interpretation of whatever, bracketing, say, and a different interpretation of bracketing. And if I compare those counts, the bigger one is going to give me the classification. And this was something that people had been playing around with variously back in the time. Also in SMT land, around the same time, Franz Ock and co at Google, what became Google Translate, were doing experiments over a scale of data that was just inconceivable to the mere mortals, the academics, and sort of showing that, well, I just need to train my language model over more and more and more data, going sort of up to web scale, what at the time was just inconceivable to anyone else. 219 billion words of web data. This is in 2005, a tutorial from Franz Ock. And this scared a lot of people. This was just Google going off in a direction that no one else could keep up with. So it's not a new thing. And there's a wonderful blog post by Rich Sutton about the bitter lesson. I don't have time to read it out, but it's basically observing that this happens over and over again in computer science, that data scale blows everything else out of the water. And we need to accept this. And the last sentence, the eventual success is tinged with bitterness and often incompletely digested because it is success over a favoured human-centric approach. So sort of ideas that we come up with in terms of clever ideas based on our intuition about how humans perform the task often give you local gains, but globally it's data scaling and compute scaling that gets you there. So what was the outcome of the story at the time? Well, of course, data scaling doesn't work across all language pairs. You need to have a lot of data. So that particular graph that I showed off was for Arabic English, for example, where you had a lot of data because of various projects at the time in the US. And not long after that, you had the neural machine translation revolution happen, of course. And if you think about what happened there, it was actually advances in computation, the arrival of GPUs and the realization that we could train these models on GPUs and use the parallelism of GPUs, as well as in terms of learning algorithms that really made the SMT work at the time and data scaling redundant. There's a wonderful paper by Naomi Safra and colleagues, which I highly, highly recommend, which reflects on this, a recent paper from Archive this year, and comes up with some very poignant recommendations in terms of the relevance of small guy research in this context. Related to this is academic intractability of commercial grade NLP, and I would simply make the point there that, again, it's not a new problem. Even 30 years ago, systems like OutJE were way beyond what you could ever imagine building within a university environment. The secret sauce at the time was data, but just of a different form. It was lexical resources, what Ikehara-san at the time would always talk about as the linear accelerators of NLP. If you're going to pay the physicists a lot of money, you should be paying us a lot of money to build lexical resources. And again, history showed us that that was a local minimum. It was an approach that was swept away by the data-driven work of SMT and more recently NMT. And there was a great example of Kodiaewa kind of sweeping away a lot of the commercial systems at the time with clever engineering and sort of scrappy startup approaches to things. So don't panic. So then, let me skip over this and talk about, there's a wonderful quote from Karen Spark-Jones, which I think really puts things in context. So this was reflections of hers in '94, the history of NLP over what she categorized as 4 epochs to that point, where she talks about old ideas reappearing in new guises, but the new costumes are better made, of better materials, as well as more becoming. So research is not so much going around in circles as ascending a spiral. So this is trying to be a spiral costume, in case you don't get the reference, if only a rather flat one. And you could argue about how flat it really is. So let me talk just very quickly, before Kawahara-san throws me off the stage, about ways where I think we've actually gone backwards. And one is the ability to comprehend data nuances. So we're spending a lot less of our time, building symbolic systems, rule-based systems, which really taught you, or building those very richly annotated data sets, which taught you to deeply engage with your data and ask very critical questions of your data and analyses of your data. And that skill set, I think, is getting lost as we sort of focus much more on the algorithmic side of things, and data sets become things that you download from Hugging Face and feed into your system. So what do we do about it? Always think critically about the task you're performing and whether a given data set is actually a good instantiation of that task or not, consistent with what I was saying about summarization, for example. How was it labeled? How it's done? What do those labels actually capture? How is it evaluated? What do those numbers actually mean? And the error analysis. We had a best paper award earlier today on error analysis. And asking why questions when you're doing error analysis as much as possible. Modularity, this is sort of flying in the face, I know, of the sort of end-to-end monolithic models, and it's more the suggestion that if we can build more modular systems where we can drop in smaller components, more specialized components, we have the architectures now where we can do training where we're dropping in components. The science of annotation, and dataset construction, it relates to what I was saying about engagement with the data before, but we're paradoxically in an era where people assume data sets. We're almost being complacent about the existence of data sets, and I think it's important to realize the true value and all of the hard work that goes into building them, but also some of the work that's being done in terms of developing more human authentic annotation methods, modeling methods using subjective labels, and standardizing evaluation and data sets differently. And then one which I was thinking about, which came up in some of the papers from '95, was regression testing. The idea that I make changes to my system in software engineering terms, I go back and test to make sure that over a standard test set I haven't broken anything. We don't do this anymore, in part because we don't sort of have that same incremental sense, I think, of system development. But if we have fine-grained data sets in terms of, well, this is a particular phenomenon which I want my system to be able to capture, and breakdown of results across these, like some of the very old ideas from TS/NLP, we get much more fine-grained evaluation in terms of how we're going with our evaluations. And I think there's real value to be had in that. I have 3 more slides. So, signs of the times. No, 4 more slides. This is a complete aside. It's very quick. I spent a bit of time playing around in the proceedings, as you're getting a sense. The first part of this is the new analysis. The second part is I was sort of thinking about, well, how has the field changed? And one of the obvious things that's changed is the average number of papers per author. We're doing sort of larger team, more big science. And maybe this is a very personal one, I'm not sure, but the proportion of co-authors who I had not met at the time of publication, so I don't have metadata for this one, of course, I can only do the personal analysis of this, but I either met my co-author later on, or I've never actually met my co-authors on papers, which was a very foreign thing to think about 30 years ago. So in terms of the average number of authors per paper, so this is ACL long and short papers versus Gengo Shori Gakkai. So actually, Gengo Shori Gakkai started higher. I think it actually had a higher industrial presence in Gengo Shori Gakkai earlier on than in ACL. So ACL has caught up and actually overtaken, as I think there's more and more industry presence. This was the scary one for me. So this is as I say, this is the TIM curve of the average number of unmet at the time of submission authors, as in I had not met these people I'm writing papers with. And I couldn't have imagined it back in '95, and in 2024, based on the papers I've had to date, there's about 40% of my authors who I have not physically met or had not met. Some of them I've met subsequently. What does all this mean? Either Tim is getting older, or Tim is getting more senior or more distracted, possibly. But I think there is, maybe those numbers aren't completely representative, but I think it is very much a sign of where our field seems to be headed towards more distributed collaboration models. I'm sure the UD people would agree with this in terms of some of the sort of all-in papers there. So final slide, where does all of this leave us? So I would say that, well, NLP is mostly in rude health, as in we're in a very good place. We've come a long way. Great progress has been made in the last 30 years across many, many dimensions. It is worth looking over your shoulder occasionally and to learn lessons from the past. And I think there are some lessons to be learned. Either it's don't panic sorts of lessons, or hey, there were some methodologies that we used to use before which probably still have relevance, but we've forgotten about them. I think associations like言語処理学会have a huge role to play in all of this, of course, and are critical to the further development of the field. And congratulations again on the first 30 years, and thanks for all the fish. ありがとうございます。